Section today is on radicals. It's going to be multiplying and dividing radicals. Here is, oh, I skipped the, where'd it go? Oh, there it is. All right, so today the objective is that you can simplify radical expressions. Exponents of one factor, and the radicand is a multiple of radical indices, or index. Radicals index. So we're going to be multiplying, we're going to be dividing them. I'll show you guys how. It's not that crazy. I am recording it, so if you need to go back and take a look at that, you can. Here's the first rule that you need to know. Combining radical expressions. So if you're going to multiply them, here's as simple as I can tell you the rule here. Okay? I know that we got this fancy mathematical jargon up there, but what you really need to look at if you want to multiply two radicals, if you will, is check the index. Check the index. If the index is the same, then you can multiply them. Okay? If they're different, then you cannot. No, we're talking about multiplying. We're talking about products. Actually, that even goes for division as well. So if I have, let's say, the third root of, I don't know, 82, and I'm multiplying that by the third root of 5, can I multiply those? Yeah. The answer is yes. And of course, if I could simplify it, then I could. But if I had the third root of 82 and the square root of 5, can I multiply those two?
Maybe.
No. There's no maybe. You cannot. Okay? So then that means if you could simplify 3 radical 82, then do that, but you cannot multiply the two values there, the two radicals, okay?
Yeah, what if you simplify that 3 radical 82?
Then that'd be fine, but you'd get some number in front of the radical 3, whatever's left over, if there is a leftover for 82, and then you'd have to multiply by radical 5, okay? So, questions on multiplying. Here's the other rule. If you want to divide them, they also have to have the same index. Right? No, I'm sorry. It just looked funny. From my angle, her phone is on in your desk.
Whose phone?
So look. Oh, is that your phone? Oh, it is.
Oh.
It just keeps lighting up. It distracts me. I'm sorry. It's like I'm shiny. And then I say Tristan, and it keeps distracting me. All right, moving on. So multiplying radical expressions. Let's get to that. Here is the third root of 6 times the square root of 2. Can I do that?
No.
The answer is no, because you don't have the same index. One is 3, one is 2. Therefore, I'm done. Move on. There's nothing to do. Okay? Looking at this one, can I multiply those? They do have the same index. They are both an index of 3, so this becomes the third root of negative 8. Now I can think about, oh, is there a third root of negative 8? The answer is yes. I can take negative 2. That would be, so negative 2 would be the third root of negative 8. You think about it, if I did this, right, I would get that negative 8 back. So negative 2 is the index there. All right, questions on that problem? Take your headphones out, too. Down to the upper right-hand corner. We're good? No, I'm fine. It's fine. I'm just waiting for you. You're good? All right, cool. How about this? Can we multiply 4 radical 7 times 5 radical 7?
No.
So what do we do?
Move on.
Move on. Exactly right. All right, simplifying radical expressions. Simplifying radical expressions. I've got this here, radical expression. It is an index of 3. So do I need to worry about absolute values?
No.
The answer is no. Correct. So is there a third root of 54?
Yeah.
I don't know. I'm going to check my calculator.
Wait, what you said?
Is there a third root of 54?
Maybe.
Let's see here. Great, do that.
4.
Is it 4? So 4 is the third root of 54. So I have 4. Let's see here. Third root of 50. So we took out the 54. The 4, sorry. Take a look at the x to the 5th. take a look at x to the fifth. And this is the way I would do that. You guys remember we talked yesterday about power over root? That's 5 over 3. It's the power over the root. So, what would that quotient be? 5 divided by 3. What would I get? Yeah, but what would the quotient be? I would get 1 and remainder of 2. Do you ever see how I did that? This 1 means I get to bring an x outside. The remainder means how many x's are going to be left inside. And we're done. Okay, because I didn't have to worry about absolute values, right?
Nope.
Everyone okay with what I did there with the division part on the x? Can I move on? Ben? What was that? Put your phone down. It'll be fine without you. Alright, moving on. How about this problem here? I've got the third root of 128 x is 7. Do I need to worry about absolute value here, Lexa?
No.
Lexa?
I would never know who you're talking to. So then you just
Yeah, I kind of mumbled the last part.
It looks.
Do I need to worry about absolute value? Alexi.
What?
Do I need to worry about absolute value in this problem? Good, because the index is
3.
odd. But
Oh,
yes,
sorry.
3 is correct as well. So I don't have to worry about absolute value. Is there a third root of 128? Third root of 128. I'm just using my calculator. It looks like I got 5.03. So guess what I'm going to have to do? Upside down cake. Let's see here. What's 128 divided by 3? 128 divided by 3. Holy, you
Why
can't.
didn't you use 2?
Yeah. Why did I use 3? Oh, because the index is 3? So 2, what's half of that? 128. 64.
Yeah.
Divide that by 2, 32. Divide that by 2, 16. Divide that by 2, 8. Divide that by 2, 4, 2, and 2. I'm circling this in sets of
3.
3 because my index is 3. So there's a set, there's another set. So I get to bring those 2 out, which means I got a 4 outside. Okay, here's my third root of whatever's left over. What is left over there?
1.
2.
1, 2. Yeah, it's okay. You almost threw me off there. All right, so there's the number part. Let's take a look at the variable part. I've got x 7 divided by 3. What's the quotient there? 2, remainder 1. So I'm going to bring 2 x's out, and I've got 1 left over for the inside. So there is my problem simplified. Woo! Questions here? Once, going twice? So, I did the numbers first. So the 128, I did this whole upside down cake business. So I took 128 divided by 2 all the way until I got all prime numbers on the outside. So it's gonna, man, that's shaky. So 128 is really 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay? For each set of 3, I can bring one of them out. So this one is one set, right? So I got 2. But then this is another set, which means times 2. Well, what is 2 times 2? And that's where the 4 came from. Now you see how I got a 2 down here that was left over? That just goes back inside. Okay? If I had 2 2's left over, then I would put 4 in there. Thank you. Oh, that's a lot. Let's make that clear. Thank you, Infinity. That's very kind of you. We just like crush her goodwill there, bro. Alright, moving on. Oh, sorry. Sorry. Somebody's writing still.
I just wrote down the rules.
You just wrote down the rules? Well, some of them need examples. We know you're very bright.
No,
supposed to be happy.
Guess what? I had to get another computer today.
You had to get another computer? Congratulations. I'd be excited every time I got a new computer.
My keyboard like doesn't work anymore.
I'm excited. You know what my boy asked me for? Well, I told you guys my brother asked me to take her to the library, right? So I'm like, yeah, I took her to the library. And then my boy's like, I want to go hiking. Can we go on a hike? I'm like, yeah.
You go hiking and then you look
Yeah,
here.
I don't run, but I can walk. Come on, man. No, yo, my boy, my little boy, my little girl, man, dude. I gotta tell him so.
As long as this hill is a straight road.
No, I got some good ones. All right, moving on. Now, oh, sorry, Dad. Change that. Sorry. This conversation went south, so I wanted to change the topic. I'm just sharing here. Yeah, actually, we are going to go north for the hike. He wants it to be cold. So like, Sedona. We did Picacho. They were upset because we went to the little kid trail. You know how you can go as you go into Picacho. If you go, what is it, west? There's like this slow, no slope kind of thing. But then you can go face on. And yeah, they were mad. So we had to take them back to that way. I'm like, yeah, this is the better one. I'm like, dude, there's rocks falling everywhere. I thought I was gonna die at some point. Like, no, mama, no. And then you woke up.
Then he started stopping.
Watching the Discovery Channel does not count.
He fell asleep eating your peppermint patty.
Alright, we're good, Julia? Alright. Thank you. Thank you. That makes you regret sharing sometimes. Simplifying a product. So, change your mentality here. Look at that. Woo, that's beautiful, isn't it?
No.
Yes, it is. So, first question I need to ask myself.
Are they the same?
Can I multiply them? Right. Are the indices the same?
Maybe.
Because are the indices the same?
Yeah.
All right, stop, guys. We're back. Thank you. Are the indices the same?
Yes.
Yes. So can I multiply them?
Yes.
Yes. So I'm going to get the square root of whatever that product is. So I'm just going to use my calculator here. Oh, I don't need to. 72 times 10 is 720. X to the 4th, y to the 5th. So let's do this. 720. Does 720 have a square root? I don't think it does, but I'm going to.
420?
720.
Maybe that's the square root.
It doesn't. It's 26. So let me slide this over a little bit. I'm going to do my upside down cake here. Let's see here. I'm going to have some stuff outside, some stuff inside. So let's go 720. If I divide by 2, I'm going to get, let's go see here, 720 divided by 2, 360. Do you guys want to divide by 3? Can we do that?
Yeah.
Yeah, I'm just going to jump to 3 so it'll go faster. So divide by 3, that'll give me 120. Divided by 3, that should give me 40. I'm going to have to go back to 2. That's going to give me, 20. Divided by 2 gives me 10. Divided by 2 is going to give me 5. I'm circling these in sets of 2. I've got a set of 3s here, a set of 2s there, and then these are another set there, aren't they?
Yeah.
So what gets to come out of that?
3, 2.
3, 2, and 2. Correct? What's going to get left behind inside the radical?
5.
My 5. Good. So there's the number part. Let's do the variables. I'm going to do x to the 4th. X to the 4th divided by 2. Oh, wait a minute. Did we have to worry about absolute value here?
Yeah.
Yeah. Because it's an even. So I'm going to throw some absolute value bars up front here. Now, 4 divided by 2? 2. Do I have any remainders?
No.
No, so this is just going to be x squared up front. Let's do the y. Y 5th divided by 2. Looks like I've got 2 remainder 1, correct?
Yeah.
So I'm going to bring 2 y's up front, and 1's going to go back inside. Okay?
Which one do you look for?
Well, let's see if we really need them there, okay? I've got 3 times 2 times 2, which is 12. Am I going to be worried about 12 becoming a negative 12?
Maybe.
Not really. Okay? And then x squared, if I put a negative number into x squared, is it going to become negative at any point?
No.
Not really, so I can just leave that as x squared. Same deal with y squared. So it looks like putting absolute value bars anywhere here would be redundant. We don't have to worry about it. So now we have this. Now again, if you want to leave them there, more power to you. Math Excel might just say that's unnecessary, or it might say simplify or something.
Well, would it get wrong if we put the...
Right, that's what I'm saying. I don't know if Math Excel. Joey, feeling all right? Anybody still writing here?
I need to get the first 2 things that multiply together.
So basically, upside down cake is sticking with us for the rest of our lives.
I like upside down cake. I mean, if you got, because I know.
Me too. It's easy.
Yeah, I like it. A lot of people do the tree, and I used to do the tree first, but then I was the kind of person that would like put some kind of composite number on somewhere and forget to simplify that, and then I don't remember which ones to grab at the end because my tree was all over the place, looked like a
Yeah.
family tree. Like, nah. So I quit that.
I don't like the tree. It's confusing.
Upside down cake's pretty cool, huh? I like it. Pineapple upside down cake, yeah. Alright, we're good here?
No.
If it's made right.
If it's made right, touche.
My grandma's cooking. That's hot.
Yeah, if I make it, it's just gonna be raw dough with some pineapple in it. It's not cooked all the way.
Just put a whole on there. Don't even bother cutting it rid of the sauce.
The way I would make it is just go down to Walmart or something. Fries. Swap it out. T-Dub, feeling alright? One of them days. Jesus? Adam? Here, you know what? Let's just do this. What? What have you been hosting? What have you been doing all year? Sid, you alright? She has a can. She has what? Oh. Yeah. Mitch Hedberg. Mitch Hedberg. You guys know Mitch Hedberg, a comedian?
No.
He was talking about corn, and he's like, you know what really bothers me? Is that we call corn, like, the way it grows, corn on the cob. And when it's off the cob, it's on corn. And like, but corn grows with the cob on it. So we should call that corn. Everything else, corn off the cob. Right? But it's true. Like,
Yeah, but you eat corn and then it comes out corn.
okay, then you just went like on a tangent there. Yeah. He goes, it's not like, you know, if I, you know, someone cuts my arm off, they would call my arm, and I'd be like, right, I mean, it's just corn. But, whatever. I guess that's why they call it kernels now? Corn kernels? Alright, can we multiply these two? Yes, we can. So, 45 times 35 is 1575. So this is going to be the square root of 1575, x to the 6th, y to the 7th. Okay? Question, do I need to worry about absolute value? Yes, I do. So, absolute value, square root of whatever's left over. Let's start with the number. Is there a square root of 1575 straight up?
I don't know.
I don't know. I'm checking too. Nope. We got 39 something. So 1575. 1575. I'm going to start by dividing by 5. That's going to give me 315. Divide that by 5. I've got 63. Divide that by 3. I should get 21? 21. Divide that by 3, I'm going to get 7, right? So, I've got a set of 5s, a set of 3s, which means I get 15 on the outside. So 15 on here. What's left inside? 7. Beautiful. Let's go for the vars. Let's go for the vars. X to the 6th divided by 2 is, any remainders? Nope. Y, 7 divided by 3 is also 3, right? But a remainder of, so I've got this with this. Now let's clean this up. Do I need to worry about 15 becoming a negative number? Not really. Do I need to worry about x to the 3rd becoming a negative number? Yes. So that will stay, and the y will stay in absolute value bars. And we've got 7y to complete this. So that's what it should look like. And if you want to leave that 15 inside too, more power to you. So. Oh, let me show you what I did. So to get that, we went x to the 6th. What is the index here? It's 2. If you don't see a number, it's 2. So what's 6 divided by 2? 3. And that's why we got x to the 3rd there. Now for the other one, this part, we've got y to the 7th over 2. That gives me 3 with a remainder of 1, right? That's why we've got y to the 3rd here, and then one remainder that goes back inside. Okay? You guys a second there? Big Red. I haven't had me a Big Red in a while. That's what I was like. No, you know what they still sell? Well, I haven't seen anything big again. Tab. This pop. Tab. T. Yeah. Sorry. Soda. It was liquid refreshment.
What does it taste like?
It's like really watered down Coke. It's really light. And they brought it back for a while, and then it's gone again. I haven't seen it. It's called Tap. T-A-B.
Yeah,
Crystal Pepsi's cool.
Hell yeah.
I think soda was better when I was a kid, because you used to get it in glass bottles, and it just gets colder that way. No, like when you went to Circle K, you can get a can, or you would get glass bottles, not the plastic bottles. And your soda in a plastic bottle gets hot real quick.
Yeah, there's hot soda in plastic.
Really? I've seen you do it in a glass bottle.
I think they have it at Skips.
Really?
Yeah, even at Target or I think Fry's too.
Yeah, I'd rather have glass bottles. So they say, she says they sell them at Sam's and Target and stuff. The only thing that I've seen in the glass bottle is you.
And they have them like in spray.
You never had you?
What's that? Chocolate milk.
Okay, it's like it's not chocolate milk.
Oh, I thought it was.
It's I'm throwing air quotes up there because it's like it's like chocolate milk, but it's not. They don't use milk. They use the whey. You know how when you make cheese, have you ever made cheese?
Baked cheese.
Yeah, you've never made cheese? Oh, I guess it's an African thing. Anyways, when you make cheese, it'll kernel, right? So it'll separate. So you get the kernels, which becomes the cheese, and then you'll get this water that's left over, which is the whey. And that stuff's really good too, but that's what they do. They take the whey out of it, and then they flavor it with chocolate.
So it's basically chocolate.
It's chocolate whey.
Chocolate water.
No, because there's
Damn, it also
Little Miss Muffet
That
eating her curds and whey.
down came with Spidey.
Except for, you ever heard that? All right, let's move on. Thank you. Thank you. Thank you. Thank you. No, but I'm going to show you how to do this dividing real quick. So, can I divide these? Yes, I can. Now, what's really cool about this, you can think about this as being something like this. You can really think about it that way. So, if I'm looking at the square root here, what is 18 divided by 2? It's 9. And if I have x to the 5th over x to the 3rd, 3 cancel, don't they? So you would get x to the 2nd. Do I have to worry about absolute value? Yes. So this would be the absolute value of 3x, which is simply 3 absolute value of x. Yeah, when you divide them, you're really... Think about it this way. X to the 5th is like x times x times x times x times x, right? And then x to the 3rd is like x, correct? Now, anything over itself is just 1, right? So guess what? That's 1, that's 1, that's 1. That make sense? Nice, huh? Go math. Because, is there anything I can really do to this 3 to make it a negative number?
You can put a negative.
No, because I put absolute value on this x. So I don't really have the 3 inside. Like I said, I don't know if Max Excel will like this or not, but nothing's wrong with either one of them. Right? I think it's just a matter of simplifying. Yeah, it does get picky sometimes. I'm not going to say it's not. Can you watch your work? Anybody still right? Yeah.
Mr. Maria, so Monday's the last day that we could retake?
Monday.
Yeah, isn't it the 20th?
Tuesday's last. But either way.
It's going to be Wednesday, isn't it?
There is no
Tuesday
Wednesday.
after break? Tuesday after turkey break?
After the break?
What? What? Tuesdays when we go on break. Tuesday's the last day of school, then we're on break.
Yeah, when we come back from break, it's Thursday. Thursday is the 30th.
We come back on the 3rd?
Yeah, so not next week, but the week after that, on a Thursday, is the 30th.
What do you mean?
That's a lot of time. I don't think that's true, man. What? Oh, wait a minute, whoa. What are we talking about? Are we talking about two different things here?
We're not retakes.
You're talking about break. Our break is next Wednesday, Thursday, and Friday. We come back on Monday. The last day to take stuff is the Thursday after break, which is the 30th. Two different conversations out there that got jumbled. Like now, we're not on winter break yet. On the 30th, after the 30th, you can't make up your old stuff anymore. For the semester. Yes.
Why did you get the 3x?
Shh, can't hear this.
Why did the 3x inside of the
Do I have to worry about 3 becoming a negative 3 somehow? So I just took it out. If I was worried about it somehow, I would leave it inside. But I'm not, because even this x, even if I make it a negative number, these bars are going to make it positive, which would make it positive again. You guys need to see that again, or you guys are good? We're good? That's the same thing. All right, rationalizing the denominator. We've already talked about, thank you. We've already talked about rationalizing the denominator in some of the previous sections, but we're going to just go ahead and throw this at you, Lexi, now so you can see it again.
I'm not on my phone. My phone's right there.
I'm not bad. I can like it from
No, it's okay. I was messing with my video.
what you mean? Are you making bigger holes on it?
No, I
That seems to be the style right now.
Trees.
I'm starting to see holes on shirts now too.
Yes. Yeah, I have to see
Like
shirts.
what? If you guys want Y shirts, I'll slice them for you. I'll charge you $1. That's it. Get some discounts there. All right. Whoa, watch your words, please. So here's this problem. We need to rationalize the denominator. And the way that you're going to have to do that is by simplifying it. Now, there's nothing really inside that I can simplify already. So what I'm going to do is kind of what I did in the last problem. Instead of keeping it as one radical, I'm going to split it up into two. So this is going to be, sorry, that's not right. This is going to become the third root of 5x squared over the third root of 12y squared z. Okay? Now, what I want to do is I want to make sure that the bottom has no radicals in it. Okay, so that's the point of rationalizing the denominator. I don't want to have radicals down there. So this is going to become the third root of something. Now, the best way that I can show you, it takes a little bit of time, but you will get there, and you probably, hopefully, with minimal mistakes. 12 can be broken up into 2 times 2 times 3, correct? And y is y times y, and then you've got 1z. Okay? Now if you think about this, we're trying to get all the radicals out of the picture. And this is the third root, so I want to make sure that I have sets of 3 for everything, correct? So when I go over to this other side and create what I'm going to multiply by, I just want to complete my sets. Here I've got 2 2s. How many more 2s do I need? I need 1 more 2, don't I? So I'm going to put a 2 in there. How many more 3s do I need? 2 of them. So I'm going to go times 3 times 3. I've got 2 y's. I need 1 more. And I've got 1 z. I need 2 more. So this will be z, z. So once I have, let's call this in the bottom, let's call this the answer, okay? That means that my denominator, it's going to be 6 y, z.
How'd you get that?
Well, when I multiply these two, I should show you without any steps there. If I were to multiply the two denominators, I would get this business. I would get 2 times 2 times 2 times 3 times 3 times 3 times y times y times y times z times z times z. Correct? Well, remember we said, and we did that on purpose because every set of 3 would give me something on the outside, right? So, the 2 gets to come out, the 3 gets to come out. What's 2 times 3? 6. The y gets to come out, the z gets to come out. So there's my new denominator. Unfortunately, the top part is kind of the tougher part. Because if whatever I do to the bottom, I got to do to the top. So I'm going to do the top part in blue. Because I multiply this denominator by 2 times 3 times 3 times y times z, I got to do the same thing on top, which is 6. No, that's not 6. What is 2 times 3 times 3? That's 9 times 2. 18. 18 y z squared. Yeah, so now I just got to multiply the two tops. So 5 times 18. What's 5 times 18?
A big number.
Third root of, yeah, I know. Is it 90? Thank you. So third root of 90, y, I should start with x. Let's start alphabetical. I like that, alphabetical order. X squared, y, z squared. It's from the first one. Yeah, this is my numerator stuff. And like I said, I'm sorry, this is kind of gross. Okay? But are we good? You okay? Any questions? Sure? Look like it. It's okay to ask. It's kind of tough stuff. I guess my only question now is, can that 90 be simplified, right?
Yeah.
So I'll just do it over here in green. So I've got 90. I could divide by 3. That would give me 30, and then 3 tens. But then that's 2 times 5. Do I have any sets of 3 in there?
Yeah. No.
No. So guess what?
You gotta do it.
That is it right there. There's not much to do. 90 x squared y z squared.
What if you did it by 2 then?
Well, we can't do it by 2 because it's a third root. The index is 3.
No, I mean like the upside down.
We would get the same thing because it's all primes on the outside. Yeah, because if we did 2, we would get 45. 3 15s, 3 and 5 again. Does that make sense?
Yeah.
Do you want me to show you?
Yeah.
Just because it's fun to do. What I'm saying is you're going to get the same setup. So even if I started with 2, I would get 45. Then I would get 3 15s. And then I would get 3 and 5. It's the same numbers, just jumbled.
When you start with 5.
Guess what? Make a conjecture. Use your inductive reasoning.
I don't have it.
Alright. Oh, that's kind of crazy there. Anybody writing this? Ben? Okay, do it again. You guys want to try this one, please? You'll need 2 more 5s and another y. Adam? All right. So for this one, you should be multiplying by the third root of 25y, right? So third root 25y. That means in my denominator, I'm going to get 5y. And since this is cubed, since it's cubed,
You don't have to have absolute values. Right?
sharing time is over. Since it's cubed, I don't have to worry about absolute values, so yay. Up at the top, I've got the third root of, what is that, 175 x y.
Ooh, I got it right.
And I know it's not going to be a third root of that because the factors are 7, 5, and 5, right? Because 25 is just 5 times 5. So if I try to simplify it, I would get 7, 5, 5 to get the 175. Does that make sense?
I'm saying, why didn't you change the top? Yeah, why didn't you change the top?
Y is what? 175?
No.
No, the top, the red, the very top.
25y?
Yeah, why?
I have to multiply by this one. Remember, this times that gave me the bottom. This times that gives me the top.
No, he's saying before you did the bottom part,
Uh-huh.
When you first put the 25y in the bottom.
he's saying, why didn't you do the same thing to the top one?
That's the golden rule. Whatever you do to the bottom, you got to do to the top. It's like if you take something from one side, you got to take it from the other side. Same idea here. I need 3 5s to be able to take the cube root of it. This was only one of them, right? 2 more 5s make 25. This was only 2 y's. I needed 1 more to get 3. That's where that came from.
How did it apply to this one, not the last one we did then? How does it, because during the last one we didn't do what we did to the bottom to the top?
Yeah, we did.
We did?
Yeah, it was kind of gross.
Yes.
It's right here, see it?
Is it 18 and then? the
Yeah,
bottom?
see 2 times 3 times 3 is 18.
Okay.
And then y is z squared.
That's what kind of threw me off.
Oh, because I didn't separate it like last time. I wanted to explain where the numbers were coming from.
Yeah, but you should have separated.
For some people, this is faster.
Yeah,
I already took my time with this one, so I thought, let's reinforce it. Questions? No. Guys, I'm done. That's all I got today. Get your homework done.